first installment of Design Patterns 101, where I illustrate how and why we create design patterns in the context of ontology engineering. So first thing to note is whenever we are focused or trying to create a design pattern, we should always have in mind some competency question that we are attempting to reflect in the design pattern. As you see here, a competency question is just represents a functional requirement for ontologies, and they're used to evaluate the quality of ontologies with respect to user goals. They're often motivated by user needs and used by ontology engineers to create design patterns that will satisfy those needs and can be reflected in the ontology. They also provide a way for us to test ourselves as we're constructing the ontologies based on the design patterns to see if we've actually accurately addressed the competency questions that stakeholders and users have provided. Now, for the sake of this demonstration, I'm going to be using the competency question you see right there in red. Has a drone crossed the Arizona-Mexico border? And this is a question we can represent ontologically, and if we have answers to it in our ontology or based on our ontology, we'll know that we've created a satisfactory representation based on user needs. Now, midway between that competency question and the ontology itself is the design pattern. We need to have some pattern that we can build off of, or at least use to address this question, and will inform the construction of the ontology proper. When we're addressing the competency questions, we require ontological representations of the data relevant to the question. So you should have an eye on the sorts of flight paths or the content in those flight paths that I was just describing. The design pattern is going to be a way for us to get there from the competency questions as I described. So for our example, we'll need ultimately representations of things like borders and boundaries, or geographic regions, so drones and speed, etc., latitude, altitude, longitude, and all of this occurring over time. Now, we'll go through this piecemeal, starting with borders and boundaries. As you can see here, I have a definition for a fiat line boundary, which I believe the Mexican-Arizona border will be an instance of. A fiat line boundary is a continuous flat line whose location is defined in relation to some material entity. Now, I'm saying that our Mexico-Arizona border is an instance of the class fiat line boundary, and what this means is just it's a particular thing out in the world that falls under the broader class of fiat line boundaries. There are all sorts of other fiat line boundaries. There are other borders, for instance, not all of which are the Mexico-Arizona border. They all fall under this class. Now, we visually represent this relationship in design patterns with an oval for the class and a diamond for the instance, as you can see here. And there's an arrow indicating that the latter is a type of the former. Moving on to geographic regions, we'll have, in this case, a geographic entity demarcated by one or more boundaries, all of whose lines are located on Earth's surface. And that's what I'll mean when I describe a geographic region for the purposes of this design pattern. Now, the Mexico-Arizona border is located in some instance of geographic region, which has parts corresponding to parts of the border. The geographic parts are associated with things like latitude and longitude, represented for simplicity by decimal values in these rectangles with no color in them. Now you'll see there's a geographic part, and it has a longitudinal value, has a latitudinal value. And if we jump over here, you can see how this connects with the fiat line boundary. So the Arizona-Mexico border is located in the geographic region, which has parts, right? It's a broad geographic region because the Mexico-Arizona border is not small, right? Like it's extended in a sense. And so this thing has parts, a geographic part A, geographic part B. Of course, it has many other parts, but I'm just representing the two here for illustration. Each of these have longitude value, latitude value. Now, moving to drones and speed at which they move, we'll see that a drone here, roughly speaking, is an aircraft designed to be powered, fly autonomously, or be piloted remotely without a human operator on board. And there's an instance drone of that broader class. There's a motion process of which the drone's motion participates, and that's just a process in which a material entity, like a drone, changes its spatial orientation over time. Now, the instance of drone, as I'm saying, participates in this instance of the motion process. And This speed, though, that's reflected in that motion process, we'll call a process profile. This is a term from basic formal ontology, which we'll get a little more comfortable with as we proceed through the course. But roughly speaking, for our purposes, a process profile is an abstraction of some relevant aspect of a given process, such as the velocity of a traveling missile or the speed of a drone. And in this case, we'll say a speed is a process profile characterized by the magnitude of an object's motion relative to a reference frame over time, and that will be associated as the other measurements with a speed value in a decimal form. Now, a drone participating in a motion process will have some associated speed value. Now, the remainder of this is going to be some measurements and a connection to time, but to illustrate that, I want to highlight first, though, that we have an object like a drone moving through space but over time. And so we have this bipartite nature of the design pattern that we need to connect together. We have both space and time. And what we're going to do is we're going to leverage a spatiotemporal region, also a class that's developed out or within the context of basic formal ontology that connects space and time together. And so it's a current entity, that is to say something that exists over time, but it is part of space-time. And so the drone's motion will occupy some spatiotemporal region, instances of which have geographic and temporal extents. And this is characteristics of all spatiotemporal regions. They both have a spatial extent and a temporal extent. You can think of them as like, four-dimensional blocks, and you can think of things moving through them over time as something like three-dimensional objects, extended over and over again like little worms floating through that four-dimensional block. Now, geographic extents in this case are associated with things like longitude and latitude and altitude values, and temporal extents are associated with things like date time stamps, as you can see here in the representation. Now, if I put all of this together, and again, I'm trying to represent, a drone crossing the border. What would I need to represent a design pattern, i.e. ultimately in an ontology, to answer that question? What I'm going to need is a drone, at least a drone that participates in a motion process that has speed, or has profile speed that has some value. I'm going to want to know that information because I'm going to want to know if the object is moving or not. And if it's moving, it's got to have a speed, right? Now, that motion process is going to occupy some spatiotemporal region. And that spatiotemporal region itself is going to be smaller than like a moment or just a pin, like a little block or a little part of the block. It's going to be extended through that four-dimensional block I was describing. So it's going to have parts. It's going to have a spatiotemporal part and at least one other, we'll say, just for the sake of simplicity. I'll call them 1 and 2 here. Now, if we just focus on spatiotemporal part 1, we'll say that has an interval extent, that is a time extent, that is temporal interval 1, and that'll have a date value associated with it. It'll also have a geographic extent, that's the spatial part, and here we'll say that's the geographic part 1, and that will have longitude, altitude, and latitude values. Same story over for spatiotemporal part 2, where we have both a geographic extent and an interval extent, and they have like or their respective nodes, the geographic part 2 and the temporal interval 2 will have associated values as well. And then that ultimately is the picture you would use when you're creating a design pattern. This is the characterization you'd use when you're creating a design pattern. It is to address or go some way to addressing that competency question that started this conversation. So again, I wanted to be able to at least make progress towards representing in an ontological way when a drone has crossed over the Arizona-Mexico border. Now, I've got here both the drone and its motion process. I've got spatiotemporal regions, etc. The last piece of this, of course, that's not represented here is that Arizona-Mexico border. And for that, I will turn this over to you. And I would like you to take a shot at adding in a design pattern like this, where the Arizona-Mexico border fits when we're talking about a drone potentially crossing over there.